Skip recording. We don't need to have that on tape. Okay. So, page 93. These are going to be situations where we are already at equilibrium. Tomorrow, we're going to be learning about situations where we are not yet at equilibrium, but we're going to start by learning about when we are at equilibrium. So, we are given some concentrations here. We are given the concentration of HCl. We are given the concentration of F2. We are given the concentration of Cl2, and we are given the concentration of HF. We are then asked to calculate the KEQ. In order to calculate a KEQ, you must first write the KEQ expression. Okay, and if you recall, the KEQ expression is the mathematical expression with the things in concentration brackets. Yeah, I was wondering what that was doing there. I'm like, maybe you just don't want to see me. It's okay, I don't mind. So in order to get full credit for this, you would need to write KEQ equals, all right? If you don't do that, you lose 0.25. So this is worth 0.25. All right. Next thing you need to write is, don't just start checking in the numbers. We're going to write the expression first. And is it reactants over products or products over reactants? Products over reactants. So we've got Cl2. Now, is it multiplying or adding? Multiplying. Beautiful. Okay. And we've got HF. That has a coefficient of 2, so it is raised to the power of 2. In our reactants, we have HCl. Has a coefficient of 2, so it is raised to the power 2, and F2. This expression is worth 0.5. Equals. All right, now you start throwing in the numbers. Okay, so we now have Cl2 is 2.0. Now, I'm going to let you in on a little secret. KEQ has no units. And because it has no units, this is the one time in your life where when you're calculating it, you do not need to put in units. Wow. Only time, yes. No, but you'll be looked at strange. I'll be like, what's wrong with you? Okay. All right, so we got 2.0, and then we're going to multiply that by the HF, which is 0.60, and that's going to be squared. And then we've got HCl, which is 0.50 squared, and F2, which is 0.40. All right, and things you should make note of. What kind of brackets are these? Square brackets, because we are designating that is a concentration. Concentration is designated by square brackets. What kind of brackets do we have over here? Round brackets. Because it is just weird. Again, it is not incorrect, but it is really weird to use square brackets around numbers. It looks like you're saying concentration of 2.0, right? In the context of chemistry, it's strange to use square brackets if you're not, either bracketing something with little square brackets in it already or designating a concentration. Yes?
You have to show brackets on that thing, or
you can just do multiplication, okay? So if you prefer to write 2.0 times, the only thing is we often get into scientific notation, and now you've got this times 10 to the this squared, and so the brackets kind of make it more tidy. So just decide based on whether it's like how it best is communicated clearly. Does that make sense? Yeah. Okay, so here we use not square brackets, round brackets. And then we chuck that into our calculator and we get 2 times 0.6 squared divided by 0.5 squared divided by 0.4 equals 7.2. And remember, there is no unit for KEQ. Is good? Okay. So it is acceptable to leave out units for KEQ and in its calculation because the units of KEQ don't really mean anything and there's no standard unit for that constant. How not to lose marks. You have to write KEQ equals, you have to show this bit, you have to show square brackets around the doodad, and you should show either round brackets or times signs for the concentrations. And I'm going to let you in on a little secret. Even though everyone always tells me that they understand that this is multiplication here and not addition, somehow or other, little plus signs end up in there. Not frequently, but every once in a while. I know the brain just goes like, psst, it has like a little short circuit for a second, and all of a sudden there's a plus sign in there. Don't do that. Don't, just avoid that, okay? No pluses. All right, so that's going to get you all your credit. Let us now take a look at a situation where instead of solving for KEQ, we are given a concentration of H2. We are given a concentration of I2. And we are asked to calculate the concentration of HI. All right, and we are given our KEQ. What do you think the first thing is that you're going to have to write? The KEQ expression. So KEQ equals, go for it. And then it is your choice whether you plug the numbers in first and then solve, or solve and then plug the numbers in. I have a tendency to solve and then plug the numbers in just because it means I'm less writing for me usually, because there's like times 10 to the whatever and nonsense like that. But it is up to you. And I would have a tendency just to solve for HI squared and then do the square root at the end. Yes. Yeah, if you were to put units in here, they would just be like, yeah, we don't just put units. We just end up with, we get to the end and we're like, oh, it's concentration. It must be molar. So you'll stick a unit on at the very end here. Yes, absolutely. Because otherwise it just looks like gobbledygoo. Yeah. Okay. And as Victoria was just saying, we get to the end and we're like, oh, look, this is a concentration. So that means we do actually need a unit. And you can just chuck it in at the end, molar. Yes? All right. Example 3, and I'm going to have to switch my other one because I accidentally used your guys for theirs. So here we are, example 3. So we have this reaction here is with 4s and 5s and 6s and 4s. We are told that it takes place in a 5-liter flask. And we are told the masses, grams of NH3, grams of O2, grams of H2O, and grams of NO. And we are asked to calculate the KEQ. Now, KEQ questions, your KEQ expression doesn't say grams of whatever. It doesn't say moles of whatever. It says concentrations. So you always have to get everything into moles per liter first. Okay, so you're going to do that first, and then you're going to plug them into KEQ. Do you feel like you would like to try that? Do you want to give it a go, or do you want me to do it with you? You'll try it? Excellent. Now, I've shown calculating concentrations in one step, but you can definitely do it in 2 steps instead, where you find the moles and then you divide by the 5 liters to find the concentration. But it's also okay to do it in 1 step. It does not matter as long as you end up at the same place. Once you've written your KEQ expression, check it with the one I've written here, see if you got the same thing. If you included water, remember water is a liquid, and do liquids have a meaningful concentration? Nope, so we do not include them in our KEQ expression. Yeah. Oh, you know what? For the regular chem stuff, do the pink because I've directed it. It's too hard to make the book twice. So I've done it like with regular chem molar masses. Yeah. Yes, I'll give you the pink sheet on the test. You won't have the blue one. When you write the AP exam, use the molar masses on the periodic table that you are given there. And it will usually be, it'll be 4 sig figs. Yeah. So usually 2 decimal places, other than hydrogen, which I think they give 3 decimal places to make it 4 sig figs. I could be wrong on that. They might just give you 2 decimal places. Yeah. Yeah. Oh, hang on. Whoops. Whoops. I'm like, why am I not raising it to the 9? That's what I did this morning. Oh, yeah. Okay. Yep. Did you round to 0.173? Don't round until the very end. Yes, but we don't round off our values till our last step. Yeah, we don't like round and then round and then round, because if you say, for example, at every step you ended up with something that was like something with a 5, yeah, you would end up rounding up. And you would end up rounding up and you would end up rounding up, but actually probably it'll all end up being too high. Yes. So rounding, my general rule for rounding is I like to either keep the number on my calculator, right? So that I don't end up rounding at all. So if I have that 0.17 and it just gives me 3s, I just leave that there and I raise it to the power of 4, right? But let's say I hadn't done that. I usually personally, I like to keep 2 places past where I need it. So I would tend to write this as if I wanted to like clear my calculator, I would probably write it as 1.733 or 0.17333. If it's a repeater like that, I'll just throw the repeater on top so that I can be like, and then I just go with it, right? Yeah. So either 1 position more than your sig figs or 2 positions more than your sig figs, and that will keep you safe, other than once there's one quiz where that doesn't work for you. I don't know which one it is. Somewhere in this course, there's a quiz where if you round off early, you get it doesn't round nicely. It's not nice. I can't remember where it is though. Anyway, that is all you need to learn for today. And that's going to get you to be able to do all of page 92, which is just writing the expressions, and 95, which is doing the calculations. If you are too busy tonight to do all of that, you can just do like every second question. Okay? Yeah.
Question 5.
Yes. 95, question number 5. This one here? Yeah. And what was the question? Sorry?
I think in XP.
Oh my gosh. Yeah, that's no good. That should be an S2. Yes, you're absolutely correct. This right here. So on number 5, that should be an S2. There we go. Thank you. Fix. Hi. Oh, you're just coming up. Never mind.